Good morning and welcome to the first session in the Red Room at VB 2014. To kick us off this morning, we have a paper that attempts to peer into the mists of time by predicting malicious domains. Could you please welcome Wei Xu and Carl Sanders from Palo Alto Networks.
Thank you, Chair. Good morning, everyone. My name is Wei. I'm coming from Palo Alto Networks, and this is Carl Sanders. He'll be my co-speaker for this presentation. Today, we're going to talk about the work we did with predicting malicious domains. It's a collaboration work between myself, Cal, and one of our colleagues, Yanxin Zhang, who could not be here today. Okay, so I'm sure everybody here knows what malicious domain is, but just for the purpose of presentation, let me go through a little bit things, information about malicious domains. They're used for different purposes. Most common ones we know for command and control, and the malware distributions like drive-by downloads, and also phishing. Those are probably the most important use for malicious domains, and of course more. The reason we focus on malicious domains is because they are used for different attack vectors, and they're pretty much show up everywhere in security threat landscape. So the goal remains the same across since the use of malicious domains is to detect and to block. And to do that, the current method mostly like this. So we have a lot of reputation-based malicious domain blacklist. So everybody trying to find and detect evidence of malicious domains, like you have some malicious JavaScript code, you have been distribution malwares, you has been embedded some F-frames, and you go through a lot of traffic redirection chains, things like that. So in general, the current approach is detect evidence of malicious content or malicious activities on the domains and put them into this reputation-based malicious domain blacklist. So seems like everything is okay, it's all good. But what's the problem? The problem is there's always a but. First, it's kind of in retrospect, meaning the detection of malicious domains happens after the malicious domains are in use. And so not just us, attackers also notice this. What they do, they make sure a lot of malicious domains only live for a very short period. So it's short-lived, meaning they're only used for a very short period of time for their malicious purpose activities. And they have been developed different evasion techniques, one of which, the most famous one, is called domain generation algorithm. So just in case some of you not familiar with the term domain generation algorithm, is that it's an algorithm used by some of the modern malwares. It will use a seed as input and generate a list of domains based on the seed. And they will keep connecting to each one of these domains on the list to make sure to check which one is live, and use that live one as potential like CNC server or things like that. So continue the problem. This is the game we've been playing right now. And in this picture, we're actually Tom. If I remember correctly, Jerry is the smart one. So put into one sentence, we are always one step behind the bad guys. So that's the scenario we're looking at. So what can we do? That's the natural question we're going to ask next. I'm not sure, probably none of you can recognize this, this picture. It's coming from the movie called Minority Report. It's saying that in the future, I don't know how far away, a police department try to prevent crime even before it's happening. The same case here. So in this work, we predict malicious domains, but not use the magic 8. It's just a symbol. So how the prediction goes? First, we want to say this is the first step towards this effort, because it's clearly a lot of uncertainty characters here. It's not like when people are talking about prediction, some people think it's not going to happen. But this is just our effort to try to make it, try to use this and work in this direction. So The whole work basically based on these two observations. The first observation is called the life cycle of malicious domains, which I will explain in details later. The second one called the reuse of valuable resources. So our philosophy is kind of like predict based on what things we already know and try to predict things we don't know. So from known to unknown. And for this work, we only focus on newly registered malicious domains. This also including domains that the registration has been changed, like from one owner to another, things like that. And so the outcome of this work is we try to provide early warning of the malicious domains. Okay, so the first observation, the life cycle of malicious domains, it goes like this. You have different phases and different steps, actually, and different steps aggregated into three main phases: the preparation phase, the activation phase, and of course the deactivation phase. It's very straightforward. So we start with select name. Imagine you're an attacker, you want to register a malicious domain for whatever purpose, you have to come up with a name. You can choose from tons of top-level domains. And you need to go to a domain registrant like GoDaddy to pay, like maybe, depends on the top-level domain you choose, from $10 to $20, $50, you can register them for a year. And after that, you have to set up a DNS record, meaning you have to let people be able to find your domain, to connect to the domain. Then you push the button. Okay, everything goes online. You can do whatever intent you have for the domain. And hopefully, very shortly, it got detected. So all the security world knows this is a bad domain, and it will be suspended, it will be locked. So more than often, this is done by the domain registrant based on the report they receive from people. Say, okay, we find evidence of this domain doing malicious activities, so you have to block it. And actually, they are willing to do this because once they block it, they kind of like, the earlier they block this domain, the earlier they can get it back and then put it on the market again. So it's just make more money. After a while, depends on who blocked and why they block it, unlock it, and resell it. So this is the whole cycle thing. Why are we talking about this? We will show you later. So based on this, we have we propose these four different types of approaches, or some of them are actually heuristics. For example, the first one is the reuse of domain names, and the second one is pre-generated domain names. And the third one is the connection between different malicious domains, and the last one is DNS queries. So this kind of like our weapon to do the prediction. We start with the first one, the reuse of domain names. So remember the cycle we just talked about. So from the time a malicious domain being registered and being used and to it being blocked and reused again, there's a time interval. Normally that thing is over a year. And so after that time interval, back to the market. And it should be cleared from most, if not all, the malicious domain blacklist, because at that time the malicious activity or content is already gone. There's no reason to keep it on the list, meaning it's a clean domain again. So this is our first observation in this kind of domains. The second observation is this domain is always maintained resolvable. Even in the case, during the phase they are suspended or blocked. And normally they're in the form of domain parking, meaning if you actually visit the domain, you can see some content over there. In most cases, it's just some advertisement thrown in by the domain registrant who owned the domain at that time. But if just based on these two, like, okay, we know this domain was a malicious domain a year ago, and we now see it's resolvable again. Just based on these two, there will be tons of domains, malicious domains, a candidate for malicious domains. So what do? We need to apply some kind of filtering, which we call probability score. This probability score is based on first the domain name, like how random it look like. Is the domain name looks like an existing legitimate domain, like for example Facebook, or be something like a F00K book, something like that. What kind of top-level domain you choose? If it's just .com, .net, or .bz, or .co.cc, we all know that. Different top-level domains have different weights, and how often it changes in the IP address. does it look like fast flux domains? And the last one is the price for domain transfer, because there's always the economy model again behind this. So based on this, based on the probability score, we can calculate how likely this domain, this previously detected malicious domains, will be used for malicious purpose again. And that's how we predict in the first approach. The second approach is based on the technique, the evasion technique we just talked about, the domain generation algorithm. So normally, understand of domain generation algorithm is that it is used for generate a list of potential rendezvous points, meaning that the attacker don't want hard-coded CNC servers into malware they distribute on all the clients' machines. Rather, they want those clients' machines to looking for the, sorry, can you still? Hello? Can you still hear me in the back? Okay. They want the malware to look for those domains, and so that they can bypass the current approach, the domain blacklist approach. But that's just the normal assumption for this. What we discovered based on analysis of a lot of domain generation algorithms is that first, there are module. Any malware can use that module. And they have been used for different purposes other than just the rendezvous points. For example, we noticed some of the malware sample actually use domain generation algorithm to generate noise. So when the malware executes, you can see a bunch of DNS requests. Most of them returns NX domains, but there are a few actually embedded, and they are not NX, and they are not part of DNS requests that looks suspicious, meaning they are trying to take your attention away to something that not being used as CNC and hide their real CNC servers. So with that in mind, the DGA is actually not that simple. The problem is to use DGA to pre-generating domains is first. We have to solve this problem. First, of course, find the DGA malwares. We have some sandbox-based technologies from which we run the malware samples and we can look for the DNS request pattern. And if they have multiple DNS requests to non-existent domains and with the domain name looks like random, we think it's a potential malware that use DGA technique. The second step is very important. We have to filter out the noise, meaning we have to identify the purpose of this, the DGA algorithm being used in this malware. Like I mentioned before, not all of them being used for potential CNC server purpose. And the third one is we have to find the DGA seed. Each DGA algorithm has a seed, and since configure is the first famous DGA sample. Since that, the seed has been changing because the attacker has realized that using the system time is not very reliable. So they have been moving to other things. For example, we noticed some of the DGA malware actually fetch the search engine page like Google or Bing. Within that search engine page, there's a timestamp field. They just use that as the seed. So the challenge here is not just to find the seed manually through reverse engineering, which works, but requires a lot of manual effort. What we're trying to do is without reverse engineering. So what we propose is actually a black box-based testing. Hello? Yeah. Wow. Feels much better. So, and the last one is each DGA domains depends on how often they activate the DGA algorithm. Will generate a list of domains like every hour, every 3 hours, every day. Basically, what we're trying to say is that if we have a lot of DGA malwares and you already figure out the DGA algorithm and you run them to predict the future domains, you will have a large list of domains. So which one of these domains will actually be used? We have to keep monitoring them. So that's the problems we're trying to solve. And the most important technique we use is called black box testing. The purpose of this technique is to find the seed. If it's first, it's most simple ones. If it's used the time, we can always change the system time and run samples multiple times. That's the general idea. And see if the hello? Hello? Try this one. Hello? Use this one? Okay. I can hold it. It's okay. Hello? Hello? Okay. Sorry. Yes, black box testing. But for seeds, other than the system timestamp, we have to do something else. For example, the case I just mentioned, if it's looking for something in a specific domain, specific web page like Google's page, we have to be able to feed that page with some of the modifications. If we suspect is the timestamp in that page will be used as a seed, we need to change the timestamp within that page and feed it to the different executions of the same malware. Then we can see whether this change of potential or input candidate will result in the generation of different list of domain, DGA domains. So that's how we do the black box testing. And with that, when we figure out the input to this, the DGA domains, we will manipulate the input. For example, it's time-based. Most common is time-based. We just change the time to tomorrow, the day after tomorrow, like that. And so we can predict the domain names that will be used for the malicious purpose. And so the third one, the third approach or heuristic is reuse of valuable resources. This is actually our second observation. This is very prevalent. When I say resources, I mean like servers. For example, bulletproof servers, you can buy these servers from online. They're normally hosted in some countries that don't care much about internet crime or they're somehow protected. But they cost you a lot comparing to registered domains. And the host and the IPs, for example, infected the host. So you can you can purchase this botnet from other attackers and use for different purposes. And of course, domain names, although it's cheap, it's going to cost something. So I guess the question probably people are going to ask is why the resources are, why the resources are reused? Well, it's money, of course. Just put it into one word. It's gone or? Because they're valuable and they can be used for gone? Yeah. Seriously? Something with me? Or? This is live? I can probably just use it. Hello? Okay. I'll just use this one. So money, of course. And we notice this reuse of resources is across different malicious activities. For example, sometimes this botnet was used to, Sometimes this, that me? Botnet was, Okay. Yep, I'll try to hold very, very still. So I think you get the idea. Connections. So let's talk about connections. What kind of connections we use in this work? First, same name servers. As we mentioned before, same DNS name servers can be used to resolve different domain names. So they are by nature reusable, and they often host on bulletproof servers. So for example, this is one of the malicious name servers we discovered. It has .ru at the end, but that's not the reason we detect it's a malicious name server. Over the time, we find it has 128 malicious domains actually use this name server to resolve their DNS records. And but not because a server resolved to different domain names, or some of the malicious domain is, so we call the name server is actually a malicious name server and use that in prediction. We have to do some filtering. For example, if the name server belongs to some domain registrants, not just the big ones like GoDaddy, some small ones too, they can be used to resolve many, many different domain names, and many of them could be malicious, but we will not use them in prediction. It could come from like CDN or web hosting, or sometimes just use once, this name server itself. We'll filter all this out. And when we find a candidate malicious name server that has potential to be used to host future malicious domains, we have this passive DNS data feed, and we search the passive DNS data feed regularly to find the malicious domains mapped to this name server. The next connection is the same IP address. This coming from the heuristic that infected host can be used for different purposes. So first is a known malicious domains IP address, each domain mapped to some IP address. And the second source of information is sinkhole identify infected host. We have our own sinkhole project that has been collecting infected host IPs. But problem again, you need to do some filtering. The purpose of filtering is to identify the nature or the functionality of this IP. For example, some of these IP are portal IPs, like they use NAT, so the infected host that's behind this IP, you cannot use this IP, obviously. Some of the cloud IPs, like from AWS, from Cloudflare, others like CDN web hosting IPs. So basically, we find that the IPs has been used associated with malicious domain before. We apply the filtering, and the rest we use them to do the prediction. The third one is the same or similar registrant information. The reason we use the different malicious domains from different times share similar whois information is because sometimes attackers like to embed some pseudo identification information like fake characters. Other cases, like a batch of domains was actually registered together using stolen credentials, and they are used over time, like one by one. So there's the connection. So how do we search for this connection? We search for registrant names, address, emails, phone numbers, and the date, registrant date. And for different types of information, when we do the searching, we either use fuzzy matching or we use exact match. The last type of approach that we use is DNS queries. Remember the life cycle of malicious domains. There is a step between you register domain name to your setup DNS server and to the actual activation. There's some time gap over there, and there will be some patterns in the DNS queries. So since we have the passive DNS data collection, we can looking for these specific patterns. The patterns, for example, when you're setting up DNS servers, or when you're modifying the DNS records, or when you're testing some DNS resolutions, this is the normal stuff people will do to make sure the DNS actually works, whether for malicious purpose or benign purposes. They're different from when the domain is up, different DNS queries coming in. So there will be different temporal patterns. For example, this is actually another case, the sudden outbreak of in DNS queries. This is used for detect and provide early warning on the outbreak of these malicious activities. All of a sudden, this domain was put in use, and all the queries just coming in. And periodic queries, this is most likely made by some automatic ways, like a code. And of course, the queue name, the query name, is DGA-like, it looks like random or look like known malicious domains. So that are the four types of patterns we're looking for. We do the prediction. And we did some evaluations as well, of course. Before the evaluation, I want to just briefly introduce the data set, because all these heuristics approaches, they have to work on a large set of live data in order to actually capture something meaningful. So the first thing is passive DNS data collection. We have collaboration with a passive DNS provider called Farset, used to be called SIE. And we also have our own passive DNS collections. Roughly, we have like 1.5 billion DNS queries coming in per day. And we have our own sinkhole project. Up to now, we already have 1.2 billion incoming connections and 208 million infected IP address. And we have the whois records. So every day, we will just query whois records for new malicious domains or the past malicious domains, see if the whois records has been changed or updated. And at last, we have the IP location database, provide the geolocation and the registering information for IP segments. So this is how we do the evaluation. First, we predict a list of, we think, malicious domains that will be used or about to be used for malicious purpose. And we publish them as part of our DNS signature. And we periodically check the VirusTotal just as a reference. So it turns out over 80% of the domains on our list eventually will have a VirusTotal detection rate larger than 1. And by the way, that's not us. We're not on the VirusTotal list. Another thing is because the prediction is about to put a malicious domain out there before they're used to give some time advantage. So we measure that by the time difference that we detect the domain as a malicious domain, and the domains actually shows up in passive DNS feeds. We think when it shows up, meaning somebody is actually doing the query and or maybe trying to use it. So on average, we have 8 hours advance the time difference between what we detect and publish the domain to it shows up in passive DNS feed. And the last one is we publish these domains and DNS signatures, and they will be applied in our product firewalls, and we can monitor how many of these signatures has been triggered. So over half of them has been triggered. But this only comes from 5 or 6 different firewalls that we have control. For the rest of firewall, we don't even know whether they're triggered or not. So, a summary. This is, as I mentioned before, first step towards the predicting of malicious domains. And we propose different approaches based on 2 observations. One is the domain lifecycle, and the second, the reuse of valuable resources. And the evaluation shows that it is actually effective in predicting malicious domains. So with that, I will take questions. And thank you guys for your patience and the change of the devices.
So we do have several minutes for questions. Is anyone up? Yep.